Right now we are importing our source from our this SOP level, from our this geometry level into the DOB, and we are emitting our fluid from the source. In here we also have an a particle fluid tank, and what that will do, it will going to create an a fill out an a water inside of domain. And if I were to create an a particle fluid tank node, let's add this, and here we have it. And if I were to visualize, and basically what that is, it will just create this an a bounding box, and it will just fill out with these flip particles. I can go into our this particle fluid tank. In here I can define the water level, and I can say how much water I want in my this fluid tank. And in here we have the particle separation. Same thing, if you were to lower down this particle separation, you can create more or less of your particles. And I can also control the size of my this overall particle pre-filled water tank. I'm going to just default it out this right now, or maybe let's increase its X size like so that we have some of the bigger size. Let's maybe increase its size onto the Z as well. We also have the option for enabling the jitter scale. If I were to change this to 0, here you can see we have the regular arrangement of these particle. And if I were to change this to 1, we have this jittery, and it is a very nice distribution of the particles. Now let's see how we can import our this pre-filled water tank into the DOP.NET, into the flip fluids. Let's go into the DOP.NET, and right now we have this continuous emission. And to actually import this or this particle fluid tank, we're not going to use the volume source node. As you know, this volume source node will going to be import all of our particles every frame, and we don't want that. We only want this tank to be only initialized at the very first frame. So let's go into the DOP.NET, and we need to define this onto the flip object. Let's go into the flip object, and here you can see we have the SOP path. Let's click on it, and I'm going to move this in here, and let's find our particle fluid tank, and here we have it, and hit accept. And right now here you can see our this fluid tank has not been imported, and that is because the input type is set to surface SOP. It is expecting a polygonal piece of geometry, but we are using the particle fluid tank. We have these particles, we do not have geometry. So let's go into the DOP.NET and onto the flip object, and let's change the input from surface to particle field, because we are working with particles. Let's click on it, and as soon as you click this, here you can see we have all of our particles imported in here. And right now they are outside of this domain, which means if I were to hit play, they will going to be get deleted. And here you can see close boundaries is on, which means that all of this will going to be collide as well. And we have this source, it will going to be add up into my this tank as well. And here you can see, let's go into the onto the flip solver, and let's adjust its domain. Flip and go into the volume motion, and here we have the box size. And we can also link this this domain size with our this flip tank. Here you can see onto the particle flip tank we have the size, which means I can just copy this parameter. Let's go into the DOP.NET, and onto the box size I'm going to say paste relative reference. Now we are using the same size. Let me rewind, and here you can see right now it is offsetted. I'm going to change this box center, and let's zero this out. And now we are using the same size. I can adjust the particle fluid tank size if I were to increase more of these particles. And let's dive inside, and here you can see our domain size will going to be adjusted also, because we have created an a link between them. Let's hit play, and here you'll see our this particles has been filled with this tank. And right now our particles are falling due to the gravity, and we also need to link the flip object this particle separation. And here you can see we are not using the same particle separation. So let's go into the DOP.NET, and onto the flip object, let's copy this parameter, particle separation. Let's go back, and let's paste this onto this particle separation as well, paste relative reference. Now we are using the same. And right now we are creating a lot more particles and it will be heavy. Let's go into the flip object and I'm going to change this to 0.1 to not import that many, not create that many flip particles. Let's hit play and here you can see. Now we do not have falling effect because now we are working with the same particle separation. And our this source is also filling our this empty tank. Right now, well, it's not empty, but you know that this domain also has some room for other fluid. So this source will eventually going to be fill up all of this. Let's go into the volume source. If you don't want to import this, I'm going to just remove the wire and we are just initializing this with the flip tank. And right now we do not have any motion, but we only have this gravity. We can also add the particle forces in here because you know that it is a combination of the volume and as well as the particle solver, this flip solver, which means we can use the particle forces in here. As you can see, we have the second input, we have the particle velocity, which means we can connect the pop forces in here. I'm going to add a pop wind node in here. Let's add a pop wind and let's connect this onto this particle force tab, this particle velocity tab. Let's hit rewind and onto the pop wind I'm going to add a amplitude of 1 and let's hit play. And here you can see we have some of the windy waves introduced in our particles. Let's add a collider in here. Right now we do not have an interesting motion because nothing is colliding into our water. Maybe let's create a rubber toy geometry in here. I'm going to add the rubber toy and I'm also going to animate this rubber toy as well. For the animation, first I'm going to visualize this fluid or this water tank, and then let's template this rubber toy. And I'm going to add a transform node and I'm going to use the transform to add the animation. Let me template my transform, select the node and press enter. Now I can just move down here. Let me enable its parameter and let's add a key. And make sure to disable this flip simulation because as you know, if I were to scrub this, this flip will also going to calculate. So let's disable this. Now I can freely go and I can just maybe move this a bit up onto this level and let's add another key. Let's hit rewind and hit play. Now let's import this as a collider. And maybe I'm going to create a null at the end for referencing, and that is our collider. Let's rename this accordingly, collider, and it should be double L, I think. Let's go into the .NET and dive inside. And in here to import our collider, we need to create a static object node. Let's add this and let me go back onto the static object. We need to define the saw path. Let's click on it and let's select our collider. Let's merge this with that merge node. Let's add this and we need to organize this static object. Let's enable our simulation. Right now it is calculating. Let me activate my camera view tool and let's hit play. It is not calculated. Let's go back and so that its viewport refreshes. Let's dive inside again. Let's try that again. Let's hit play and here you can see this animation has not been imported, which means we need to go into the static object and let's enable this use deforming geometry because we have the animation built in. Let's hit play and now we should see the movement. And now this object will going to be create some splashes in here, and here you can see this collider is working. Maybe I can introduce another collider in here. I'm going to also let's adjust this and add a crag geometry in here. Test geometry crag. Let's view this. It has animation built into it, this geometry. Let me view this and template out this crag so that I can see where my crag is. I'm going to translate this to add the offset onto the Z. Let me maybe place this in here. Right now, I think our this fluid level is below the ground. So let's fix this. Let's go into the particle fluid surface and I'm going to just increase its center. I'm going to increase this center to maybe a value of, I think the value of 2.2 is looking fine. And we also need to go into the DOPNet and onto the flip solver. Let's change the box center as well, 2.2, so that we have at the same location. Let me hit rewind and hit play. Right now I cannot see my particles, and that is because of the particle fluid. We need to adjust the water level. Let me find onto the particle fluid surface. We have the water level and it is in minus. Let's increase this to, we can adjust the water level. I'm going to fill it like so. Let's go back onto the DOPNet and let's hit play. Okay, we have the rubber toy, but we haven't yet imported our this crack geometry. So I'm going to go back. We have the crack. Okay, let's add a static object in here. Let's add static object, and into the saw path let's select our crack geometry. Let me find, here we have the test geometry crack. Hit accept and make sure to enable the use deforming because we have the animation built in. Let's merge this and also organize this node graph so that we have all of the collider onto the left side. Right now we have them. Let's hit play, and here you will see that our crack will going to create some splashes in here. Right now I cannot see them. What I can do, I can go into the merge node and onto the collide relationship. Let's change this to mutual. Sorry, the effector relationship, let's change this to mutual, which means everything will collide with each other. Let's hit accept, and here you can see this crack geometry is still not interacting with our fluids, and that is because if I go back and visualize my this crack geometry, and if you press and hold the middle mouse button, and here you can see by default this crack geometry is an opaque geometry, and this static object that we have just created is not designed to work with opaque geometry, which means we need to unpack this first. So let's add a unpack node, and I'm going to connect this, and now it should create an irregular polygonal piece of geometry, and now we can reference this into there. I'm going to go into the DOPNet and onto the static object. Let's use our this unpack node, and now our this collider will work. Let's hit accept, and here you will see that collision will going to be happening. And let's give him some few frame to simulate. Let me zoom out a bit. Let's hit play again, and right now there is not quite a lot happening. What I can do, I can go back and maybe let's increase the scale. Let's increase the uniform scale to a very big value so that I want to really see some of these splashes that it is creating. Let's hit play, and here you can see our collider is working. Both of our colliders are working because we had the crack very small and it was just not creating this velocities, it was not adjusting, but now it is working. The collisions are happening, and here you can clearly see its hammer is actually interacting with the particles, and we will pick up more detail when we are going to create a more high resolution of our this flip simulation. If I go into the flip object and lower down the separation, let's lower this down to maybe a 0.05, and here we will see that we will pick up a lot more detail with the lower particle separation because we have a lot more resolution. But our collider is working, and here you can see our this crack is moving out these particles. Right now our this simulation is slow. I'm not going to use that many particle separation. Let's lower this down to 0.1, and maybe let's not import our this crack in here as well. And down here we are using right now pop wind. We can add some other forces. Let's say I can add a pop access force, Let's add this, and to use both of them we can just connect this like so. Let's go into the pop axis, and I'm going to increase its radius, and let's also increase its height. And onto the speed, I'm going to increase its orbital speed to create this swirly type, this whirlpool type animation. Let's hit play, and here you can see we have a whirlpool at the very center. I can continue increasing this orbit speed, and here you will see our particle will going to be accelerated. And I can also enable the lift speed. If I were to change this to 1, our particles will going to be lifted up onto this y-axis. Right now they are not lifting. Maybe let's continue increasing this, and let's hit play, and here you can see we have this lifting effect. And I think I can add the minus force. If I were to change this to -5, now our this particle will going to be sink down. And I think we need to create the minus because whirlpool just swirl our particles, and the particles will going to be going down. And we also have some other option. We have the suction speed, and that will just suck out our particles at the center of the sphere. I can go back onto the shape, change this to another shape, and here we'll see some interesting motion. And here you can see you can use any of the particle forces to control the fluid particle motion, and that is the particle fluid tank.